All right, so it is Monday, February 1st at 6:05, and let's go ahead and kick off the Kahoot challenge. So here we go. Question number 1. Which definition below best describes the term unicast? All right, that's correct. Good. The majority of you got it. So unicast is information transmitted to a single device, and that's what that UNI means. Unicast, it's to one device. All right, let's see what we've got here. So Jeremy in the lead, ahead of Shane, JP, Tyler, and then Lee. On to question number 2. Where is the startup configuration file stored? And again, all of these questions come right out of the reading. In fact, what I do is I just scroll through the reading and I pick out interesting questions from there. Good, the majority of you got this, right? It's in Nvram, right? And the key there is the N and the V for non-volatile, right? Meaning that if the router were to get unplugged or reloaded, that what sits in Nvram will still be there. Remember, the difference between the startup configuration and the running configuration is the running configuration is the configuration that the router pulls into RAM, not NVRAM. So it pulls the startup configuration when it boots up. It takes the startup configuration and loads it into RAM and is running it in memory, right? Which is why when you're making changes to the running config, if you don't save the running configuration and the router gets turned off, you lose those changes, right? So that's why it's always good to save things periodically. So it's the non-volatile random access memory. NVRAM is where our startup config is at. All right, let's see what any shift in the standings. Still the same 5 on the leaderboard. On to question number 3. Which definition below best describes the term multicast? All right, outstanding. Good response on that one. Information, right? Multi, right? Meaning one or more. And so information that's transmitted to one or more devices. To the leaderboard we go. All right, Shane is in fuego with 3 correct answers in a row. On to question number 4. Which symbol below is representative of the privilege exec mode? And after this week, hopefully we've got a good grasp on this one. And the modes are always tough when you first work with them, but then you'll get used to them. All right, again, excellent, right, good. It's that pound sign, right, or the hash sign is sometimes referred to. That is indicative of privilege exec mode. Remember the greater than symbol, right? That's for user exec mode. All right, Jeremy with a streak of 4 in a row. Shane, JP, Tyler, and Lee in the lead. Here we go on to the next question. Which definition below best describes the term broadcast? All right, again, excellent, good, 9 out of 10, excellent. So yeah, broadcast is information that's transmitted to all devices, right? So we talked about unicast, we've talked about broadcast and multicast, I should say. Now we're talking about broadcast, which is broadcast out. It's the same thing, right? If you broadcast something over a loudspeaker, anybody within listening, range is going to be able to hear that. And so that's a broadcast. All right. So Tyler creeps up into second, Shane down into third, but he still has 5 in a row. All right, on to question number 6. Where is the running configuration stored? We know it's not in VRAM, right? All right, good. 7 out of 10. Yeah, remember the running configuration, right? Which when the router boots up or the switch boots up, whatever the device is, it pulls the startup configuration out of NVRAM into memory. So remember, your running config is in RAM, right? It's running in the memory. And so it's in RAM. So let's see, we've got any movement on the board? No movement on the board. On to question number 7. Which command below will change the switch hostname from the default to switch or SW-01? And this is a little tougher, right? Because we've got some CLI syntax here that you're going to have to look at. And actually, now that I look at it, yeah, so it would have been this command, but for some reason, hostname, you can see I'm missing the hostname command or the hostname portion of the command. So it would have been the bottom one here had we had hostname in here. But bad question, or bad answer for the question. So we move on. Jeremy's still in the lead. On to question number 8. Which keystroke sequence, when in any config mode, ends the configuration mode and returns you to privilege exec? You got it. It's Control Z, right? So if you do Control Z, it'll dump you back into privilege exec mode if you're in like an interface configuration mode or some other sub configuration mode or global config mode. It'll put you into privilege exec mode. All right, the top 3 got some points, and here we go. On to question number 9. Which symbol below is representative of user exec mode? And we should know it's not the £, because that is privilege exec. Good. Yeah, it's the greater than symbol. That is your user exec mode. All right, Danny shows up on the leaderboard in 5th place. Shane with 9 in a row. Shane is on fire. On to the last question. So it looks like it's going to be Shane, JP, and Jeremy. Whoever gets to this one first, ahead of the others, is probably going to be the winner. So here we go. Number 10. What is another way to describe privilege exec mode? You got it. Yeah, it's enable mode. You would say because the command to get into privilege exec mode is enable. And so it's commonly referred to as enable mode in addition to being called privilege exec mode. All right, so here we go. Let's check our podium standings out so I can write this down here. First, second, third. All right, so JP in third, Shane in second, and Jeremy in first. And Tyler and Lee were the runners up. All right, so the 3 podium spots. So Jeremy, Shane, and JP, in an email in Canvas, send me a good mailing address, and I will send you guys out sticker packs tomorrow, as long as we don't get snowed in and the post office opens up. All right, any questions over any of the questions that you guys saw in the Kahoot? Any questions on any of the Kahoot stuff? Let's get Packet Tracer open here. All right, so what questions do you guys have on the activities or any of the material that we've read, or the Packet Tracer activities that we've done, or something that we're going to be coming up and doing here shortly? And remember, as a reminder, if we take a look at our syllabus, and please make sure you're checking and, more importantly, reading the emails that get sent out. So this week, you've got IP assignment 1, IP assignment 2, the chapter module exam 1 through 3, and something that popped up this evening. Make sure that you are not blocking cookies with your browser. And I recommend either Firefox or Google Chrome when you're working with Netacad. I would not use Internet Explorer when you're working with Netacad. IE is always problematic. So Firefox, Google Chrome, and make sure you're not blocking cookies, or else you're going to have issues. And then we've got skills 1, the initial configuration and passwords that you're going to be doing as well. So any questions on this? What we've got for week 2? Hard to believe we're already in the second week.
I have a question over some of the stuff in week 1. It's not exactly something we did, but something that came up to me. Is there a way to reset the enable password?
Yeah, there is. So all you would have to do, and let me pull up a switch. Wait, when you say reset, you mean you're locked out?
No, I mean like
just change
it to go back to nothing, so you don't need a password to use it.
Oh, yeah. All right. So here's what we're going to do. I'm going to go ahead and say network devices. And actually, let's go to the miscellaneous, and we'll use the switches. Right. So 2960 switch. So here we are on the switch. And the switch is going to boot up. And we'll go from, again, user exec to privilege exec. And once I'm in privilege exec, I go to global config. So if I was to say enable secret ABC123, and then say do show run, you can see here we've got this enable secret command. If I wanted to get rid of that, I would say no enable secret. And then if we said do show run, it's gone. So the way to get rid of a command that you've entered is to simply precede that same command with the word no. So if you were to put an IP address on an interface and you wanted to remove it, you would say no IP address 192.168.1. whatever, right? And so to remove the privilege exec password, we just simply say no enable password or no enable secret. Does that answer your question for you?
Yep.
Cool. And it's like that on real Cisco routers and switches that behaves the exact same way. Same thing. All right, good question. Good question. All right, so everybody was supposed to bring a question, and there should be some questions based off of some of the things that I left for you in your feedback. Who else has a question on anything we've covered to this point?
So for one of the labs, I'd gotten like some of the points taken off because I totally forgot how to do like the password. What was it asking? It was like a password encryption. Because I know it's not the enable secret one.
The one that gets
You're talking about the console line passwords? Or the console line or the VTY line?
Enable service password.
The enable one.
Password encryption.
Oh, right. So you're talking about encrypting the passwords, or basically using the changing the plain text into a type 7. Is that what you're asking?
Yeah.
Yeah. All right. So here we
are. I
looked
back at it today and I saw it and I was like, shoot. And then I couldn't remember what I did.
No, that's okay. So if I say do show run and I hit enter, you come down, you can see on the console line, right? And the VTY lines, there's no password set. So if I say line con 0 and I go into the console line configuration mode and I simply say password ABC123, and then I'll put login, right? So that you're going to get prompted for that when you go to log into the console line. And then I'll say line VTY 0 to 15. So remember, when I say 0 to 15, I'm covering all the VTY lines that are here, right? If I only said 0 to 4, and then I said password ABC123 and login, let's say do show run, go all the way to the bottom, and you'll notice here that if I only do 0 to 4, it only configures 0 to 4. It doesn't configure 0 to 5 to 15. So when we're working with the VTY lines, especially on a switch, you want to make sure you say line VTY 0 to 15, and then login, password ABC123. Whoops.
I mean, what was the command to do the password encryption on overall?
Yeah, I'm going to show you that right now. Because,
oh, okay.
Yeah, what I'm showing you is, so we've got these passwords set, right? But the passwords are in plain text. So somebody looking over my shoulder would be able to see that. And we want to obscure that, right? We want to encrypt it, so to speak. So the command, if I exit out and I go to global config, is service password encryption, or password dash encryption. And that's the command. If I say do show run, now do you see the difference?
Yeah.
So instead of ABC123, you end up with a type 7 password that is, again, for shoulder surfers, meaning somebody looking over your shoulder, that is going to be a lot more difficult for them to look at and remember than, say, ABC123, right? Because somebody looks at ABC123, they're going to know that right off the bat. Now, the question becomes, well, this is, it's a type 7 password, and it's using what they refer to as a Vignere Cipher, right? That's what generates this sort of random string of characters. And the problem with the type 7 passwords is there are a million sites out there on the web, and let's pull one up right now that you can go to where you can crack that password. So if I was to say crack type 7, and you can see it already, I've typed crack type 7 and it all comes up with a bunch of options. So we'll use this one here, which I've used before as a demonstration. And if I paste in that cipher string and click crack password, you can see it cracks it within a split second, right? And so typically the question that learners will ask is they see this and then they see how easy it is to crack it. And they ask, okay, well, why does Cisco, at least with the simple passwords here, like we're using, why is it so easy to crack the password? Why don't they make it more difficult? So there's other ways that you can protect things. But again, the type 7 password isn't to keep out the wiliest of hackers, right? It's not to stop the, the black hat hacker that's going to try to crack into your router. It's for the shoulder surfer. Again, it's for someone that's like walking by or looking at what you're doing, and they're trying to see maybe what the console password is, right? Or if you were to say enable password, and remember that's the difference, is this is very important with the enable password, right? If I say enable password ABC123, and then I say enable secret ABC123, right, you'll see that we have 2 enable passwords. And so my question to you is, which one of these 2 passwords, again, if they were different, which one takes precedence? Does anybody remember?
Is it secret?
Yeah, exactly. Good. It's going to be the secret. And you can see that the secret, when you look at the hash that's generated here, which is this, that random string of characters, that's a lot more difficult to look at and to try to remember. And it's a one-way hash, right? Which is different than the Vignere Cipher, because this is going to require some work to try to crack, right? Whereas the password, the type 7, and that's what these numbers represent. It's the type of password. right? So we've seen type 7 and we've seen type 5. When you can use a type 5, that's the recommendation, right? So the enable secret using a type 5, that is recommended in place of using type 7. Because again, the type 7s aren't too secure. Because as you just saw, right? I mean, if I can figure that, if I can write that string down or memorize that string, I can dump it into a website and I could crack the password right away. Whereas this, that's not going to work, right? That's not going to work. All right, so is everybody clear? And again, realistically, right, I know they had an activity that showed you where these were both set, and then they explained to you that the secret takes precedence. But the reality is, if they're both set and the type 5 is better, then the type 5 is what you would use. And you would not use the enable password. So you would not have both of these set. There's no reason to have them both if you're already using the enable secret. And remember, the enable secret is the type 5. So how do I get rid of the password? The enable password type 7 is you simply say no enable password ABC123. Or I'm sorry, I don't have to say that. No enable password, and I say do show run, and you can see that it's now gone, right? All right, so as part of our participation tonight, let's go ahead, everybody get Packet Tracer opened up. Everybody go to the miscellaneous folder, and everybody drag a 2960, like I've got here. Go ahead and drag a 2960 out onto your canvas, the blank canvas you're working with here.
So while we're doing that, can I just ask a question?
Yeah, absolutely. Absolutely.
It's really, I mean, it's probably of no importance. It's almost like a splitting hairs question, but since secret 5 is so much better, is password just left over from yesteryear, or why even have it?
Yeah, and that's a great question. So the answer is yes, right? The type 7 is sort of a legacy type thing. And again, remember, if you think about it in the context of, when the internet first started up and, technology was coming out with routers and switches, security really wasn't that big of a concern, right? Because everybody kind of assumed that everyone was going to play nice. And then, of course, human behavior being what it is, you had bad actors who started to hack into different systems. And so then one of the first things that some of the companies did, Cisco being one of them, was they came out and they said, okay, well, we'll do type 7 passwords. And then those became crackable, right? They became very easy to figure out, again, as I just showed you. So then they said, okay, well, we're going to come out with a better scheme. So we're going to come out with type 5. So in this course, we'll talk about type 5 and we'll talk about type 7. And give me a second here while we're doing this. I'm hoping that this is going to work. And of course it doesn't. So you've got type 5 and you've got type 7, but keep in mind that the type 5, right? The type 5 password with that hash, that those are still not the best option. And so what I'll show you now on a real Cisco switch, because I'm 99% certain that it's not going to be supported in Packet Tracer. So let's take a look at a real Cisco switch. And you guys can see this okay?
Yeah.
Yeah.
Yep. See that okay? And I actually picked the wrong device. Give me 1 second here. We want to switch. There we go. Where's that switch at? Here we go. All right, you guys can still see this okay?
Yep.
All right.
Yeah.
So let me go into global config, right? And you can see when I logged in here, it put me into privilege exec mode right away. And I've configured it to do that because, again, this is a switch that I run at my house. It's not as if I'm powering, or this switch is connected to nuclear secrets or anything. So I go right into privilege exec so that I don't have to wait and, enter the password in. So here we are in global config. So let's go ahead and say enable enable secret. And now I'm going to do a question mark and take a look at some of the real other options that are available. So there's my type 5, right? If I enter in just the password itself and I say enable secret, I could type in plain text, but there's these two other types. There's a type 8 and a type 9, right? And so the best practice today is to use either the type 8 or the type 9. But again, right, we're just kind of starting out and we're kind of getting our feel for, okay, the type 7, and this is what it looks like, and here's some of the weaknesses. And then we see the type 5, and the type 5 looks a lot better than the type 7. Again, if I go back onto the switch, I mean, that is way more complex than the type 7. You would agree, right? So now watch what happens if I come over here and I say, enable secret ABC123. Oops, sorry, I don't want to do that. We're going to say enable algorithm type, right? I'm going to change the algorithm to type 9. And type 9 is what we use at the agency I work at on where we can on every single device. And you're going to see why in just a second. So I say enable algorithm type 9, which is the script algorithm. And this is by far the most, type 9, we say script. And this is by far the most secure. And so that's the command, enable algorithm type script secret. And then I'll say ABC123. And I'll say do show run. And now let's take a look at that string. Do you see how long that is? Right? So that string, that hash right there, is much longer than the MD5. And the algorithm that's being used is much more complex, right? So again, we've seen what a type 5 looks like. We've seen a type 7. Here's what a type 9 looks like. But again, it's all going to depend on your use case, right? And what exactly it is you're working on. So if you're working on, you know, your lab equipment or a packet tracer activity, you could use type 7s, you could use type 5s. But in the real world, you're going to want to think about a type 8 or a type 9 by changing the algorithm that's being used. Does that make sense?
Yes.
Okay.
Yeah.
All right. So that is the difference. So go ahead. What other questions do you guys have?
Just could you recall that command really quick? I want to make sure that in my notes I have it correct.
Yeah, oh, absolutely.
Especially like where the dash is.
Yeah, no worries. So it's right there. It's enable algorithm type.
Dash type.
Yeah, algorithm dash type script secret ABC123. And I just ABC123 is what I put in there for the password.
Sure, just an example. Okay, perfect. Thank you.
Yep, you got it. And again, in the real world, that is what you would use if you can, right? Because again, not all devices support that. But if it's there, that's what I would recommend that you use. All right. So what other questions do you have? Any questions on the activities?
What specifically am I supposed to do for the participation?
Oh, yeah. So we're going to get to that with the switch we just dragged out there.
All right. I didn't know if I missed it or not.
Oh, no. Sorry. Yeah. So the participation every week, it'll be Packet Tracer. We'll be doing something in Packet Tracer, right? And so we were going to do that, but I just want to make sure there were no questions before I moved on.
I had a quick question.
Yep, fire away.
So since there's, like you said, secret 5, 7, and 9, like, are they just different algorithms for different passwords? Okay.
Yes, they are. Yeah,
Gotcha.
they all use, so the type 7 uses a Vignere Cipher. The type 5 uses what's referred to as MD5. It's a hash, right? It uses that MD5 algorithm. The type 8 uses, I can't remember what 8 uses. Let's scroll back here. Type 8 is going to use this PBKDF2, right? And type 9 uses script. But type 9 is the best. And one of the reasons that type 9 is the best is because if you're trying to do a brute force attack, right, which is just you're sitting there trying to guess over and over and over again, every time you're guessing, it becomes exponentially more expensive for the next attempt, the next brute force attempt. And so that's one of the cool things about that algorithm is it's extremely secure, which is why, all things being equal, go with the highest number, which would be your type 9 here, right? That script algorithm that you would use. Again, if it's available. Here in Packet Tracer, you'll notice if I say enable and I do a question mark, we only get 2 choices, right? Because again, you guys are kind of just learning the material, but I want to make sure, because it was a great question. And I love questions like that that show that you're thinking about, well, okay, well, should we even be using the type 7s? And what about the 5s? Are those actually super secure? Because again, in the real world, things are a little bit different than you might see them in some of the activities that we do. So those are great questions. So does that answer your question about the difference between the 5 and the 7 and the 9 and the 8?
Yeah, it definitely does. It just makes me question as to why people would want to use like a less secure way of protecting their system.
Yeah, so human nature, again, typically you'll find that most people will do their due diligence to try to make sure they're doing the right thing. But in some cases, people just take, they do what they know or what they've learned or what they saw, and they don't really do any additional investigation to figure out, is this the best way? But again, right, I'm not trying to cast shade on people that do that. But again, right, it's about use case. Like in my home lab, like I'm not setting passwords on routers and switches in my home lab, right? I don't do that because I just need to get onto that equipment, and I don't care if that equipment gets hacked. It's in my home lab, because believe me, if somebody's able to get into my home network, the least of my concerns is that they're on one of my lab switches, right? So
yeah,
again,
so it's just like minimal security for something that like wouldn't really do much damage.
yeah, right.
Okay.
I mean, and there are some things, again, as you get into 230, you'll start to see that for some things, you have to use a type 7 password when you're doing authentication with PAP and CHAP. There's these 2 protocols, PAP and CHAP. And with those, you can't use a type 5 password. It has to be, type 7, right? So again, it's all these little quirks and things that you'll find out. But just remember, the type 7, that's to stop the shoulder surfer, right, from seeing in plain text what your password really is. And the type 5 is just a little bit better, a little bit stronger. And think about it this way as well. Yeah, so somebody gets logged on to the console line, right? Remember, if I was to go ahead and say exit, I exit out, I hit enter. Remember, we set the password ABC123. Okay, well, I just got logged in via the console line because I was able to see the type 7 password on the console line, memorize it, go out to a website, and crack it. So now I plugged into the console port while you're at lunch. I've plugged into your switch, and now I'm on the console port. But watch this. What happens when I say show run? When you log into the console port, I don't have privileges to look at your running configuration, right? You have to be in privilege exec mode. Think of that privilege exec mode as like super user. And you're like the supreme being, and you can do whatever you want on that device. From user exec mode, I can't see the running config. So, okay, they were able to get here this far, but now, even if they had a printout of the running configuration, that type 5 password is not going to do them any good, right? This is a one-way hash. that is, it uses what they refer to as a salt, which is those first characters right here are the $1, right? That's part of the salt, like this random thing that gets thrown in there. They're not going to be able to reverse engineer that by having seen it, right? So this is a little more protection on the privilege exec password, right? Where you would want it. Because on the privilege exec password, if it's a type 7 and they shoulder surf you and they're able to remember that Vignere cipher, which is crackable, now you've got a problem. With this, you're going to be pretty safe from someone looking over your shoulder, right? It's going to be a little bit more difficult than typing it into a website to figure it out. And this is going to be pretty difficult to try to remember, right? Unless you're writing it down on a piece of paper or something like that. So does that kind of answer your question as to why with the enable password, the enable secret? So it's kind of tough because I say enable password. I don't want you to think of the command enable password. So with the password that we configure for privilege exec mode, saying enable secret is what you would want to do in Packet Tracer. In the real world, you would change the algorithm type to be type 8 or 9. My recommendation is 9 because that is the best. It's the most secure thing you can do, right? All things being equal. All right. Any other questions before we dive in here to the Packet Tracer?
Where in the command exactly do you tell it 8 or 9? So
it's when you define, yeah, it's a great question. So it's when you're defining, oops, let me pull this back here. And let me make this, I apologize, let me make this a little bit larger here because that seems a little bit small to me just looking at it. Let's see if we go to 36. Oh, and it's not going to change. All right. So it is when you were to say, if you say enable, and if I do a password, you can see the algorithm type. So this is, you don't actually say 8 or 9, right? You say MD5 would be type 5. Script is type 9. And SHA-256 is type 8. And you just have to know that based off of the names of the algorithms. And then when you say show running config, that is where you would see the number show up, where it would indicate that, hey, this is a type 8 or this is a type 9. And so right now, if I was to say script secret and do a question mark, I just put in AACC123 and we say do show run, you'll see here that now it tells me that is a type 9. And you can see how much longer how much more complex this hash is, excuse me, than the type 5, right?
Got it. Perfect. Thank you so much.
Yeah, no worries. No worries. All right. What other questions do you guys have? No other questions. Any questions on the reading? No questions. All right. So here we go. So this will be, and again, this is going to, we'll be manipulating this file the whole time. So what I want you to do right now on your Packet Tracer canvas, you're going to drag out a 2960. You're going to drag out a second 2960 out of that miscellaneous folder. You're going to drag a third 2960 out. Now, here's what we're going to do next. We're going to go to our Connections tab. You're going to grab a copper crossover cable, and you're going to connect these together, and I'll let you pick what ports you want to use. I'm just going to go ahead and use gig 01, and you're going to connect the 3 switches in a straight line. And this is, does anybody know the term for what I'm doing here by connecting these together in sort of a line? Does anybody know what this is called?
A topology?
So it's a topology, but in terms of the connections to the switches, right, where it's one after the other, and if we added a fourth, it would be after another. Does anybody know what that's called?
Sequential? Daisy chain?
Yeah, say that again?
Sequential?
A bus.
No,
Or
it's not. Whoever said sequential, you said the right thing after sequential before.
daisy chain.
Thank you.
Yeah.
This is called daisy chaining, right? Where you simply just hang one switch off of another switch. All right, so here's what we're going to do now. Oh, go
Quick
ahead.
question.
Sure.
Well, when I connect the switch 0 to switch 1, which ones do I select?
Which ports do you select?
Yeah.
Yeah, you get to pick.
Okay.
Your pick, right? This is your choice. So all you want to do is make sure, and let me enlarge this. I apologize. Sometimes I forget to. Whoops, don't want that. Hold on. We don't want that.
It can be the same one, right?
It cannot be the same one.
Okay.
Right? So
Yeah.
remember, if I mouse over this and you see I'm using gig 01 between these, I can't use gig 01 over here because I've already used it over here. Does that make sense?
Yes.
So once you use the port, right, you can't use it on the other side again because it's already used up. We've plugged something into it. All right, so is everybody with me so far? And again, if you're not with me, speak up and we can pump the brakes. I want to make sure that everyone is following along here. So we're good. All right, so everybody's with me. So now here's your next task. Going from left to right, in other words, starting with the switch on the left and then going to the switch in the middle and then going to the switch on the right. We're going to name these. We want the display name and the host name to be in this order. Left switch is going to be switch 1, middle switch, switch 2. The switch on the right is switch 3. So go ahead and knock that out right now. And again, you could type switch out, or you could just say SW1 is good enough, or S1 would be good enough, right? But make sure the display name and the host name for each of the switches is the same thing.
I'm having a brain freeze on how I'm not a brain freeze. I forgot how to change the name.
All right, take a look. You see my screen?
Yeah.
What tab am I in?
Well, when I go to click on the switch, it doesn't give me an option to change my tab. All I have is a CLI.
So up across the top where it should say CLI physical config attributes, you don't see that?
Nope, I only have CLI.
And did you drag out a 2960 out of the miscellaneous folder?
I grabbed it. I hit switches and I hit 2960.
Did you go to the folder right here? You see the folder?
No, that's not where I grabbed it.
All right, so go to the folder that says miscellaneous.
Okay.
And then those are the 2960s you want to bring out.
Okay, I don't see 2960. I don't have that option.
So are you running Packet Tracer 731? If you click on Packet Tracer and then go to About Packet Tracer, the version should show 731. And my guess is if you don't have that folder, or if the folder is there and the 2960 is not.
Wait, I'm sorry. Where do I go to tell?
You would go up into your menu where it says, are you on a Mac or Windows?
I'm Windows.
All right. Up on the menu, somewhere up on the menu up here, when you click these options for Cisco Packet Tracer, it should say About Packet Tracer somewhere. And do you see that?
Nope.
Is anybody else running Windows?
Go to the help. It should be on the help one.
I'm running Windows.
Under help?
About. Okay. It says I'm running version 7.2.2.0418.
And there is the issue. So remember, you needed to download the latest version of Packet Tracer, which is 7.3.1 from the Netacad site. From the
Okay.
Netacad
Yeah, I
site.
already had this one, so I just assumed it updated.
Never assume. Never assume. Yeah, so you're going to want to go out and download the latest version of Packet Tracer. All right. So for you, since you're not going to be able to use these 2960s, yeah, you're going to have to get the latest version of Packet Tracer. And I would start downloading it right now, try to get it installed. And because we're going to be taking a break here in 5 minutes, and then we're going to take a 10-minute break in 5 minutes. And then when we come back, we'll pick back up and you'll try to catch up during that time. Okay. Are you still there?
Now, does it make a difference where you get the 2960 from?
I was
I
just
pulled
about
it
to
out of the
ask that.
switches thing, not the miscellaneous folder, but it is a 2960.
It does make a difference. It does make a difference because if you get it out of the folder, does anybody know the difference? And let me ask you guys, what is the difference between a 2960 or the 2960 that's in the miscellaneous folder and the 2960 if you just grabbed it off of the switches down here like this and came over here and said 2960? Does anybody know what the difference is?
The iOS.
Absolutely.
Okay.
Because on this 2960 here, if you click on the switches and you grab the 2960 here, this is running 12.2. You can see it right there, the software version. The reason that we don't want those is because these switches, the 3 that we're pulling out of the miscellaneous folder, these are running 15.0, which is a more recent version of the code, right? Okay, so we have our 3 switches lined up here, and we've got our 3 switches connected together. And again, you can pick the ports. Has everybody changed their display name along with the name, the host name? And
How do we update our, okay, real quick, sorry.
Say again?
How do we update it?
Update Packet Tracer?
Yes, sir.
Yep. So to update Packet Tracer, you would go out to Netacad. So let's come out here to Netacad. Whoops. Come out here to Netacad. Let me get signed in. And two-factor authentication. And let me put my two-factor authentication in. All right.
Now, so I'm sorry, will I have a whole nother packet tracer on my thing, or is it just going to go on my other one that I have on my desktop?
So it should install it into its own folder, and it should be its own installation, right? So you're going to have to go get that Cisco Packet Tracer and launch that.
Okay,
So,
I have it installing right now.
Okay.
It's
So
almost done.
Good. So when you log into Netacad and you go to, and again, you land on the little screen here, up at the top where it says resources, you can see way down here, it says download Packet Tracer. Now, remember, I said Packet Tracer 7.3.1. Do not download 8.0.
Oh, crap. Okay.
You might be able to get away with it, but I'm telling you, we're using 7.3.1. So come down to the little previous version section here, and you've got your Windows Packet Tracer versions. You've got, if you've got Linux, if you've got a Mac, you want version 7.3.1, right? 7.3.1, because that's what we're going to use throughout the whole course. Okay. Are you good? Everybody knows where to get Packet Tracer? Yep. All right. So we've got our 3 switches together here. We've connected these 3 switches up. So now the last thing we're going to do before break is on each switch, we're going to put an IP address, a switch virtual interface. And on this switch, it's going to be 192.168.1.1. And it's going to have a subnet mask of 255.255.255.0. Does everybody see what I just put there, the little note? So this will be the SVI for this switch here. And I'll say SVI for VLAN 1. So there is the information for that switch, meaning switch number 2 is going to be 192.168.1.2. Switch 3 will be 192.168.1.1. 2.168.1.3 for its SVI. So let's go ahead and configure those 3 SVIs. And you don't have to put the text out here. I'm doing that myself, right? Just so you guys can see the values that we're going to have on each of the 3 switches in question. Whoops, grabbed the wrong one. So does everybody see that okay? So there's our values for these SVIs. So somebody give me the commands that I would run on switch 1.
I have a quick question.
Yep, fire away.
So why is it that they're all VLAN 1 when they're separate things?
That is a great question. That's a great question. I love this question, right? So you buy a new Cisco switch, right? Or a switch that's had the whole configuration wiped off of it. When you buy a brand new Cisco switch and you open it up, open the box up, you take the switch out and you set it out just like we did here in Packet Tracer, and you turn that switch on, by default, all ports are in VLAN 1. And there's a reason for that. And let me throw that out there to you guys. Why do you think that is? Why is it that Cisco, when they ship their switches, put every port in the same VLAN? Why do you think they do that?
Make it easy to configure them all.
Well, let me ask you that. You're close, right? So if you would have stopped right when you said make it easy, full stop right there, you would have been correct. Do I have to configure anything if everything is VLAN 1? What do you think?
Okay, so that's more of like a port type versus a naming convention. Then VLAN 1 is more like how it's traveling.
Yeah, so here's what I want you to think of. I would write this down because this is going to become very important. A VLAN is a subnet, is a broadcast domain. If you don't do anything, if you don't write anything down tonight, write that down. A VLAN is a subnet, is a broadcast domain. Those are synonymous terms when we're talking about VLANs. And so let me take a step back. What is a VLAN? Do you guys know what VLAN stands for? What that means?
Virtual LAN.
Yeah. Virtual Local Area Network. Why is it that we have VLANs? Do you guys, does anybody know why we have a VLAN or why we have VLANs that we can configure?
I mean, I would assume just to be able to make it easier to group together a set of hosts.
Right.
Is
right.
it easier for like wireless connections?
Yeah. So I can have a VLAN for all of my wireless access points, right? That's legit. I could have a VLAN for my human resources department. I could have a VLAN for my engineering department. I could have a VLAN for the payroll department. And remember, each of those VLANs, a VLAN is a subnet, is a broadcast domain, right? And so if I wanted to segregate those departments so that only the HR department can talk to the HR department, and only the PCs and the hosts in the what did I say? In the engineering department can talk to each other, I would put them in their own VLAN. Because what a VLAN allows me to do, right, and on this switch, if I click on the switch here, whoops, and we take a look at the physical view, and I apologize, I don't think I can make this any larger, but do you guys see the ports here on the front of the switch? Does everybody see that?
Yep.
Yep.
So by default, all the ports on this switch, they're all in VLAN 1, meaning they're all in the same subnet, they're all in the same broadcast domain. So and back to the answer to the question where, and I can't remember, I don't know the name of the gentleman that said, because it's easy. And this is exactly why Cisco does this. They ship everything on all the switches set up with all the ports by default in VLAN 1, because somebody that's not a Cisco expert, right, or versed in Cisco can take that switch out of the box, plug all of their PCs and stuff into that switch, and they're already in the same VLAN. They're already in the same subnet. They're already in the same broadcast domain. There's no configuration that needs to be done. And that's why Cisco does it. And again, once you get beyond, oh, I'm just going to plug things in and I want everything I plug in to talk to each other, and you, again, progress to, well, I don't want anybody to see the payroll department servers. That would be a disaster, right? So I want to put them in their own VLAN. Now you would want to create another VLAN, and we'll see how you do that. But again, back to this, right? So all of these are in VLAN 1. If I wanted to say, I only want these ports on the left, those are going to be VLAN 1, and I'm going to create a new VLAN over here. And the green VLAN, that's going to be my HR department, and they're going to be VLAN 51. And the VLAN numbers range from 1 to 4094. So obviously you can create quite a few VLANs. And realistically, you're not going to be creating 4,000 VLANs to plug things. It doesn't work like that. But they give you the option here that you can pick a number. Again, 1 is the default, or you could pick 2 or 3 or 4 or 10 or 100 or 1,000, right? So you've got a really nice range that you can pick. But once I do this, right, on a layer 2 switch, which is what this is, once I do this, any PCs I plug in over here in the HR VLAN are not going to be able to communicate with any of the PCs I plug in over here on the, we'll just say it's the, engineering VLAN, right? Does that make sense? Are you guys still with me?
Yep, that makes sense now.
Okay, and hopefully that answered the question. And again, you know, and I apologize if it's like simplistic explanations and examples, but I want to make sure that everybody is kind of with me in terms of what we're talking about. And so right now, we're only dealing with a single VLAN. We're dealing with the default VLAN, which is VLAN 1, because again, it's an introductory course and they don't want to make it overly complicated by having you start out by like, oh, we're going to create these VLAN, because we haven't even talked about subnetting yet, right? So it would probably get lost in translation if we're creating all these VLANs and like, why are we doing this? And what is a /24 and what's the subnet mask mean? So we're not there yet, right? But again, I want to kind of broach the topic so that we're at least making some progress on topics you're going to see later on down the road. So VLAN 1 is on all of these switches. I take them out of the box, I plug them in just like this, and they're going to be able to communicate with each other because they're all using the same VLAN, and they're only using that VLAN on these ports. All right, so here's what we're going to do. We'll take 10. I'm going to shorten the break this week because, again, we're all at home. So we're going to come back at 7:15. Any questions before we take a break? And again, we'll configure the SVIs. And if you haven't done that yet, go ahead and knock that out. And I'll show you how to configure that. And then we're going to start to add more things into the topology, right?
So I actually I went and downloaded the 7.3.1.
Yep.
And an error popped up and says this existing file is marked as a read only. And it says I need to either, it says I need to abort, retry, or ignore. Every time I hit retry, it comes up with the same error.
And this is on your Windows PC?
Yes.
And
I've had that same problem. All you do is simply delete the old Cisco packet tracer because it's trying to overlap that same file.
yeah,
Okay, so I won't need the old one anymore.
No.
you're definitely, no, 722, you definitely won't need.
Okay, let me do that then. I'll try to do that. Okay.
All right, so we're going to go ahead and we're going to take a break here, and we will come back.
I actually have the 7.3.1, and the issue she was having where it wouldn't do, where you can't click on it and configure it. I have that issue, and I actually had the 7.3.1. I had to download it last week because whatever packet tracer I had before wasn't working. And just to see if there was an issue, I wiped out the file because I store everything on a secondary hard drive just for organization. And then I did a fresh install from the same setup that I had from last week, and I'm still running into the same thing she had.
Really? Okay. Are these laptops that you guys own, or are these?
This is my personal desktop.
Okay. So yeah, you should be able to get it installed. What you might end up having to do is opening up a ticket with Cisco, which is, I hate to say that because that's the last thing I want to have to do. But you should be able to install it. If you've got admin privileges, I would think you would be able to install it on your PC.
I have it installed. I have Packet Tracer open on my screen right now. I have everything except for the VLANs. I was just thinking for the time being just to terminal in and then configure everything since they taught us that so far. But I guess I'm running into the issue which she had before, and I don't know if that's an issue with a crossover of the other packet trace that existed, something in the DLLs, or whatever I downloaded, because I got the 7.3.1 because it was a straight file I got from Netacad. And I'm still running into the issue where when I take it from the miscellaneous file, it only opens the CLI, and when I open it up from the switch section, it only opens up the CLI.
And so you're saying you're running 731 right now.
Yep.
And you're opening up the switch out of the miscellaneous folder, the 2960.
Yep.
And it's only showing you the CLI tab.
Yep.
Yeah, it shouldn't be doing that. It shouldn't be doing that. So yeah, we'll have to try to figure out why it's only showing you the CLI tab.
I'm going to try CCleaner and see what that does. And then hopefully that'll, if I do that as far as the removal, it might do something different. If not, I'm not sure.
Yeah, and I'm not sure either. And it might come down, like I said, to having to kick a ticket open with Cisco to try to get it installed. So what I'll do going forward is I'm going to show you, even if you can't get the name to display as the display name, we can still go onto the CLI, put the host name on there, and then continue through. So I'll try to make it so that, irrespective of whether you're able to get to the config tab or not, you can still apply the configuration and do what we're doing.
Mm-hmm.
Yeah, I just completely uninstalled everything, all the packet tracer, and I'm kind of just starting over with 7 point.
Okay, good. All right, well, let's take our break, and what do we got? So we'll come back at 7:20. We'll take a little 10, 11-minute break, and then we'll pick back up from where we are right now. Let me pause. All right, so we are back from break, and we've got these SVIs that we want to configure on the 3 switches here. So what we would do is we would go to the CLI, and who wants to walk me through the commands that we use for the CLI?
If no one else wants to do it, I can do it.
Go right ahead.
All right. So you already configured T. So you're going to use interface and then VLAN 1.
Yep.
And from here, you're going to do IP address, and then for VLAN 1, it's 192.168.1.1. And then you're going to use the subnet, which is 255.255.255.0.
All right.
And then no shutdown will turn that interface on.
Absolutely, right? Yeah, got to remember to do the no shut here in packet tracer, right? So that it comes up. So what command, somebody different, what command could I run from this mode right here to show me all of the interfaces and what they're configured as? with IP addresses and stuff, or if they're up and down.
Is it the do show run?
So do show run. Yeah, that's going to give me, so yeah, I got some work to do here though. Yeah. And I can't really tell from that which interfaces are up, down, administrate. Well, you would be able to tell administratively down from down, but is there another command that would give me just the interfaces?
I can't remember the whole thing, but isn't like a IP interface, BRIE, and then you can
Yeah, so do show IP interface brief. Good. And this is going to show me all of the interfaces and only the interfaces that are configured. And you can see we've got VLAN 1 here. All right, so let's do VLAN. I'm sorry, we'll do the VLAN 1 SVI here on switch 2. And while I'm doing this, can somebody tell me what is the purpose of putting a switch virtual interface on these layer 2 switches? Why do we create SVIs on the switches?
Why does Nate get so toxic in Siege?
Say that again. I could barely hear you.
Sorry, my bad. Someone else is in the room and they were speaking.
Oh,
What was the question again?
Yeah, so the question is, why do we configure switch virtual interfaces? I mean, what is the purpose of me configuring this switch virtual interface on the switch? I mean, what does it do?
I can't think of like what it does, but I know it would probably help if like you had to troubleshoot and something was wrong, if it was connected to another like end device.
And how would we troubleshoot? What are some of the, how would you troubleshoot?
Well, it's like how when it had different like MAC addresses depending on, because these are layer 2 devices.
That's right. These are layer, so right.
So if it wasn't connecting because it was configured to level 3, you would have to.
So we could use it to test connectivity. So right now, from any of these switches, go ahead and ping the other switches. So if I'm on switch 3, let me ping 192.168.1.1. And I should be able to ping 192.168.1.1 or 1.2. Because again, they're all in the same VLAN. They're in the same broadcast domain. They're in the same subnet, which is 192.168.1.2. Is everybody with me so far?
Yeah, I have a question.
Go ahead. Yeah, definitely.
So I accidentally for switch 2 put the IP as 192.168.1.3. How do I fix that?
All right. So you guys tell me, somebody help her out. How do we change the IP on her switch virtual interface? How do we do that?
Would you just do the same process you did again, but just with the correct IP?
You got, who said that?
Xavier.
Xavier, well done. So did you hear that answer?
No, it was very quiet. I just turned my volume up a little bit more.
That's okay. That's okay. So what you would do is you would just go back into interface VLAN 1, rerun the command, and put in the IP that you want. Does that make sense?
Yes.
And then it overwrites that bogus value that you put in there that you didn't want.
Thank you.
Another question? Sounds like there's another question.
No, I think I'm just really behind because I haven't put in any of the IP addresses yet.
That's okay. Go ahead and keep plugging away.
I'm trying to remember how to do it. Oh God.
So you've got to go into global config, and then you go into the interface for VLAN 1 or interface VLAN 1 because we're creating a switch virtual interface. So back to the reason that you would create a switched virtual interface.
I'm in global and an interface, but I don't have.
You would say interface space VLAN space 1. If you're in global config, and you can see where I'm at right here in the window. Do you see this here?
Yeah, I'm in config and then I'm at global. I clicked on global.
So you hit enter. And then this is where you put in your IP address.
Oh, wait, I'm supposed to be under CLI. I was under config.
Yeah, you want to be on the CLI right now.
Okay.
Correct. And the command that you would use is right here on the screen. Do you see what I've got up here on the screen?
Yes.
And there's the command. So you would go into global config with conf t or configure terminal. And then you would type in interface VLAN 1. And then you would add the IP address in. And it's same process on all three switches.
Sorry.
But the IP is different for all three switches. So
yeah, I see them in the notes.
Yep. So switch 1 would be 192.168.1.1, switch 2, 1.2. So that last octet is going to be different on all three switches. And that's what you're going to be getting into this week, right? So the IP address assignments for this week, you're going to be doing binary to decimal conversion. You're going to be doing decimal to binary conversion. You're going to be going from decimal to hexadecimal, right? So we'll be doing a lot of that this week with the IP assignments. All right. So everybody's able to ping between their switches, correct?
That's how you
Yes.
the draw.
Okay. All right. So here's what we're going to do now. So now we're going to come back down here to the devices, right? You see, we've got all these devices we can pick. You're going to click on the in devices, the second choice over here in the top row. And then that opens up the PCs for us. And so we're going to drag 3 PCs out. And 1 PC is going to get placed under each of the switches. Everybody still with me here?
Yes.
All right, cool, cool. Now we're going to grab 2 servers. All right, we're going to spice things up a little bit. We're going to put a server over here, and we're going to put a server over here. So one on the left-hand side of our topology and one on the right-hand side. And now here's what you're going to do. You're going to change the display name. Again, if you can, you're going to change the display name on the first server on the left, and we're going to call it left-server, right? And then you can go ahead and close the window down. On the right server, you're going to go into config, and you're going to call it right-server. So change the names of the 2 servers to left and right, respectively. And then on the PCs, we're going to do the same thing, except the PC under switch 1, we're going to call PC1, PC under switch 2, PC2, PC under switch 3, PC3. So go ahead and do that. So PC1, oh, whoops. Yeah, so go ahead and do that. Make sure from left to right, it's PC1, PC2, and PC3. Whoops, PC3.
Sorry, do we have to get these PCs out of a certain file?
So you would get them down here in the bottom left-hand corner.
Okay, just regular PC.
Yeah, the second choice is in devices, and then you would drag 3 PCs out and 2 servers out. Oops.
Okay, I dragged those out.
And then you're going to change the display name. Again, if you can, change the display name so that the left server is the name is left server, the right server, the name is right server. And then PC1 under switch 1, PC2 under switch 2, PC3 under switch 3. Is everybody here so far?
Yep.
Anybody not here yet?
I'm almost there. I'm just changing the servers' names.
Cool, cool.
Question.
Go right ahead.
So Some of my switches aren't pinging correctly.
Some of your what?
The switch, like I pinged switch 2 from 3, and it says the success rate is 0.
It says this accessory is 0?
No, success rate is 0%.
Oh, success rate is 0.
Sorry.
So double check on all of your switches, specifically the 2 that you're working with, and make sure that the SVI in VLAN 1 is up. How could you check to see if the VLANs are up?
I know what I did wrong.
I know what you did wrong too. That's why I'm asking you to check if your VLANs are up. Yeah, this is definitely not the first time I've taught networking, if you're wondering.
No,
Yeah,
I didn't think it would be.
At all. I enter in the IP address for each ones, but it keeps saying invalid input.
You need to go back and add the 255.255.
Have you put your subnet mask on there?
Yeah.
Yep. On both of them, on all 3 of them, yeah.
Okay. And so then you've got your IP and subnet for each of those for VLAN 1, and they're all in the up state, correct?
How do I check it if it's in the up state?
Somebody give me the command. Well, you don't even need the command. If you look at my screen, hover over the switch, and it should kick up a little pop-up dialog like that is one way to check.
Okay.
And
no,
so
they're all down.
They're all down. So now go into your switch.
I'm sorry, I wasn't looking under the gigabyte. It says up, yeah. No, it says down for VLN 1.
Yeah, for VLAN 1, if it says down, say do show run and go down to the bottom where the VLAN is at. And does it say shut down?
Nope.
What about on all 3 switches? Does it say shut down on any of them?
Yes.
For VLAN 1.
Now I'm really confused. I'm not seeing shutdown on anyone.
Okay, so let's do this. Do you have the dashed line between your switches, connecting your switches up like I have?
Yeah. Okay,
so let's go to switch 3 and type in ping from privilege exec, ping 192.168.1.3. And what do you get?
192. Invalid input detected.
Invalid from privilege. Are you in privilege exec mode?
Are you in config?
I'm in config, yeah.
Yeah, so you want to be in privilege exec.
How do I get in privilege exec?
So you could say exit.
Oh yeah, exit. Okay, yep. Now let me try pinging.
I got my pings to work, by the way.
Okay, excellent. Good.
It's loading. It says success rate 0%. Okay.
All right, so here's what we're going to do. We're going to troubleshoot your issue. Who's that talking?
Samantha.
Samantha. All right, Samantha. Let's do, where are you at here? Samantha. There you are. All right, Samantha. So I am going to see if we can make you the host. So do you see a little pop-up asking you to be host or telling you that you're the host?
Yes.
All right. So go ahead and share your screen so that we can see your screen and we can see your packet tracer activity.
Okay.
All right. So there we go. All right. So I want the rest of the class to help Samantha troubleshoot the problem she's having. She can't ping. Go ahead, you guys, as a team, work it out.
Hover your mouse over SW1. Oh no, don't click, just hover.
Yeah, I just accidentally tapped on it.
All right, we got link is down. All right, go to SW2. And then SW3. All right, so they're all down. Click on SW1.
Do you remember putting the no shutdown?
I did not.
No.
You know what? Nope, I did not do no shutdown.
That's probably it.
That's your problem.
So do I do that down?
And then a
No,
space.
space shutdown, or shut for short. And if you do that to all three of them, then it should be able to ping.
Yeah, just press enter and then exit. And like type in exit.
I'm on the all for it one.
And then go to the next switch. Do the same thing.
Sorry, guys.
No, you're
It's all
fine.
good.
No, this is good. This is good.
Being able to teach it helps us make sure we know how to do it too. So
that is absolutely right.
Yeah, I made this.
Yeah, I just got delayed because I had the wrong packet tracer download. So I was.
all
Does
good.
it matter that it looks like she's running the 24 TT?
Yeah, she pulled, I think she had pulled those out prior to doing the, I think if you go to the folder, once you get done here on your last switch, I'm going to have you click, you're running 731 now. You said, Samantha, correct?
Yes.
Huh.
Okay.
I thought shut. It isn't the abbreviation for shut. Oh, you're not in the config IF.
You're right.
Yep. Good.
And then I can't remember what's the next one.
Interface and then VLAN 1.
There we go.
You got it.
Now let me try pinging. It's 1 and then 1. So
Yeah.
3.
Okay.
Oh, which one are you in?
I'm in 3, but I'm pinging 1.
Yeah. 1.1 is number 1.
2 should fail, 3 should pass.
There we go.
Yep. And if you do it again, all of them will pass.
Okay, perfect. Thank you.
So let me ask you guys.
Now I should be all caught up.
Why are the first two failing?
Because they going through switch 2 and then stop there and they got to find their way through it, or
Yeah, you're close. You're close. And so this is probably going to be the next conversation we have because this will be very important.
This is
And
making
Lee-
it a routing table.
So routing table, but routers, those are layer 3 devices. The
ARB table?
switches are layer
table.
2. Say again?
ARP.
He said an ARP table.
ARB table.
So there is an
Yeah.
ARP cache, right? And
Tyler.
there's also
Oops, sorry.
one other table on the layer 2 switch. And Samantha, do me a favor. Go down to the little folder down there in the bottom left and click on that folder.
This one?
Yeah. Okay. Yeah. The 2960s right there. So that would be going forward. You would use those little 2960s right there.
Yep.
Okay, cool. All right. So go ahead and let me see what we got going on here. I don't know if I can take
Do you want me to stop sharing?
control. Yeah, give me a second here. Yeah, so we'll talk about the ARP in a second. I just looked at the chat. So I think I can take back control here. Give me a second and let's do participants. And let's say that. Yeah, I think you've got to, or no, there we go. Yeah, go ahead and stop. There we go. Good. Yep, stop sharing. And I will go ahead and assume I should be the host and I should be able to share my screen now here. Oh, go ahead, stop sharing your screen.
Yeah, I stopped sharing it.
Oh, that's interesting. It says host disable. Oh, is there an option for you to Because
It
I
should be
saw
from the
reclaim.
top
There it is. I was
drop-down
looking
bar,
for
I think.
the reclaim button. There we go. I got it. Yeah, the reclaim button was not where I thought it was going to be. All right, so there we go. So you guys can see my screen again, yeah?
Yep.
Okay, good. So we left off here. We talked about the pings and how the first couple pings are going to fail. So, well, they might not fail now because we've already pinged. But initially, when I ran those first pings, like from switch 3, if I try to ping switch 1, I saw the period, and then I had the 3 dots. And my question was, why do you think that is? And someone said the ARP table, but there's another table on layer 2 devices. Do you guys know what that table is? That has to do with forwarding of frames at layer 2. Does anybody know what that table's called? All right, so it's called the MAC address table, right? And if you remember the OSI model, we have the 7-layer OSI model. Is everybody familiar with that? Is anybody not familiar with the OSI model?
I know what it is, but I don't have the layers organized in my head.
That's okay. Yeah, and you don't need to, right? Because we're only interested in, and this is definitely not drawn to scale. So what are we doing here? So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. So there's 7 layers. We start at layer 1. Layer 1's the physical layer. So like an Ethernet cable, right? Or the wires of the Ethernet cable, that would be considered layer 1. At layer 2, we have and this is referred to as the data link layer. So I'll just put data link layer. And at the data link layer, there's a value here. There's an address here, right? And again, when we say a switch is a layer 2 device, this is the reference we're making. We're making that reference to the OSI model. In layer 2 devices, forward traffic based on the addresses that you find at layer 2. And those are MAC addresses. And a MAC address is a 48-bit value. In fact, let's come to switch 3, and here's how you can see the MAC address table. Say show MAC address dash table, or just show MAC and then ADD and hit enter, and it should show you the MAC address table. And what do we see here? Well, we see that for VLAN 1, we have these 2 MAC addresses right here. Now, the way I'll refer to these going forward, the MAC addresses, is just using the last 4 characters, right? And these are hexadecimal characters that you're seeing here. And that's important. Again, this week, you're going to get introduced to hexadecimal and how to do conversions and stuff like that. So typically, you'll just say, oh, 9821 refers to this whole MAC address. I'll just give you the last 4. And then 2 Baker, 1 Alpha refers to that MAC address. And so these are the layer 2 data link addresses. And then at layer 3 of the OSI model, we have IP addresses. Is everybody kind of with me here on the different layers, and at least the first 3 layers of the OSI model? I'm going to leave the rest, 4, 5, 6, and 7. We're going to leave those for a conversation at another time. Because right now, these are the only 2 layers that we're really concerned about. Layer 2, which uses MAC addresses, and layer 3, and a layer 3 device. Can anybody give me an example of a layer 3 device?
A router.
Mm-hmm. A router would be a layer 3 device, right? Because routers are delivering traffic based on the layer 3 address, the IP address, like 192.168.1.1. So my question to you is, do we have any routers here in our configuration? And it's kind of a silly question, right? Because what are the devices that we have?
Switches, servers, and PCs.
Yeah, we have switches, servers, and PCs. There's no routers here, right? So then my question is, when I type in the ping command and I say ping 192.168.1.1, what's the process that takes place? How is it that the switch knows where to send out which port to send that traffic? What do you think? Because these aren't routers, right? These are layer 2 switches. So what value is it that they're using to make that decision?
Is it the IP address?
So it's not the IP address, right? Remember, IP would be layer 3, and these are layer 2 switches. So what is the address that these would be using?
The MAC address.
MAC address.
Exactly. The MAC address, right, Ricky? It's the MAC address. No, so DNS, so DNS is not involved here, right? There's no DNS involved because we're using the IPs. So here's what we're going to do. Here's what I want you to do. The server on the right-hand side, come down to the lightning bolt, and we're going to pick a straight through cable, right? Which is the straight, not the straight black line, the undashed black line, the contiguous black line. You're going to pick that. You're going to click on the server. There's only one choice for an interface. It's fast Ethernet 0. You're going to pick that, and then you're going to drag it over. You're going to plug it into your switch, and you pick the port you plug it into. You plug it in any port you want. I'll plug mine into fast Ethernet 01. And then you're going to do the same thing for the server on the left-hand side. You're going to pick that solid black line straight through Ethernet cable, fast Ethernet 0, and you're going to plug it into the switch, and you can pick any port you want. Your choice, right? Now you're going to do the same thing. You're going to do the same thing for all 3 PCs. Pick the solid black line, click on the PC, pick the fast Ethernet 0 interface, and connect it to any port on the switch. And do that for all 3 PCs. So when you're done, both of your servers and all 3 of your PCs should be connected with a solid black line into their respective switches, right? So take a few seconds and knock that out, because now we're going to talk about how the traffic is being directed through this layer 2 environment. Does everybody have their PCs and servers, or let me put it this way. Does anybody not have their PCs and servers plugged into the switches?
Which port do we plug the PCs into the switches, or is it anyone?
Any port you want. Yep, you pick the port. Can be any port you want. All right, so here's what we're going to do now. On the left-hand side, you're going to click on the server, and it's going to open up the server config tab. You're going to click on fast Ethernet 0. You're going to click on the interface, and static should be chosen. Now you are going to pick an address to give this device. But remember, the first 3 octets need to be 192.168.1, and it can't be an IP that's used anywhere else in the topology. So go ahead and pick an IP and assign that IP, and then hit tab, and it'll fill in your subnet mask for you, which will default out to the correct value. And then you're going to do the same thing on the server on the right-hand side. Click on the right-hand server, click on the fast Ethernet 0 option right here on the left-hand side of that little box that pops up for that server, and then put in an IP address. And again, remember, it has to start with 192.168.1 dot some value that's not being used, or else we'll end up with duplicate IPs. All right, does anybody not have the server IPs entered in? Okay, good. So here's what we're going to do now, because now we're going to walk through what is actually happening when we enter that ping command, because we don't have any routers, but we don't need routers, right? Routers are a layer 3 device. If I was going between different VLANs, different broadcast domains, different subnets, a router would be what I would need, right? But we're all in the same VLAN, we're all in the same subnet, we're all in the same broadcast domain. So on the right-hand side server, if I click on it and I go to the desktop tab here, and I open the command prompt up and I say ARP-A, that's going to show me the ARP cache of the server, right? And you can see it says no entries found. And what that means is, say again, yeah, go right ahead.
You mentioned routers for different VLANs. Would we need a router if we had one of our switches set up as 2 VLANs?
If you wanted to do inner VLAN routing, yes, you would. And there are switches that are called multi-layer switches, which are not what we're using, but there's multi-layer switches that actually do routing. And it's a terrible name because they should have just called them routers. So there are layer 3 switches called multi-layer switches where you can do routing, but the switches we have are all layer 2 switches. So these are not capable of doing routing based on the layer 3 information. These switches at layer 2 use the MAC addresses. That's how they're figuring out where the traffic is supposed to go. And here's how that works. So if I say ARP-A, you can see I don't have any entries here, right? So let's come over to switch number 3. If I click on switch 3 and I run my command show MAC address table, you can see that I see what the MAC addresses are that are plugged into this switch. And I see the port on which I learned what that MAC address is. And the reason this is important is because if I learned about these 2 MAC addresses down here on the bottom, on gig 02, which is this port on switch 3 right here, if I learned about those MAC addresses on that port, that also means that to get to those MAC addresses, I send traffic out that port to whatever's on the other side, to the next device over. And then that device would look at the MAC address, the destination MAC address, to figure out where do I go next. So back to switch 3 though, you can see we've got these 2 MAC addresses down here, right? That we learned on gig 02. But then I learned about this one here on fast Ethernet 01. Well, if I mouse over that, you can see that fast Ethernet 01 is the server. And so the server's MAC address for server, right server, is 8 echo 2B. Now your value may be different, right? But mine is 8 echo 2B. And I can check that over here. If I say ipconfig/all, there is the physical address. This is the burned in address on the Ethernet NIC, the network interface card that's in the server. That's its layer 2 address right there. Here is its layer 3 address, the IP address. So by saying ipconfig/all from the command prompt here, I see the layer 2 information, the layer 2 address, and I see the layer 3 address. Now, this ARP-A, I don't know about anybody else's MAC addresses right now. And in the ARP cache, right, what Address Resolution Protocol stands for, ARP, it's a mapping between a layer 3 address and the corresponding layer 2 address. Because here's my question to you. If these are all layer 2 switches, can they route the traffic using the layer 3 IP? Or do they have to have the MAC address? What do you think?
It will use both the IP and the MAC address, because I know it collects both of them, but I don't know which one it sends through. I believe it's the IP.
Yeah, so here's what happens, right? When I say ping 192.168.1.20, now this is the IP address I believe I put over here. Let's double check. Or 1.10, sorry. I am 1.20. So if I try to ping the server on the other side, right? So I'm on the right-hand side here. I'm going to try to ping the server on the left-hand side. Now, I know the layer 3 information, don't I? I know that the layer 3 IP for that device is 192.168.1.10 for the left server. But what I don't know and what I don't have is an ARP entry in my ARP cache telling me how to get there via layer 2. Because again, these are layer 2 devices. They're going to use the MAC address. They're not looking at the layer 3 information. In fact, when I enter this ping command and I send this out, what I'm going to be saying here when I hit enter is my server is going to send out an ICMP echo request or an ICMP request packet, and it's going to try to ping the other side. But before it does, or I should say, as it's doing that, it knows or it sees that it doesn't have the layer 2 information it needs. It doesn't have the MAC address. And so what it's going to do is it sends out an ARP request, an address resolution protocol request. And what that request says, or what it's asking for, is it goes out and it goes out to whoever has the IP address 192.168.1.10, and it says, hey, whoever owns this layer 3 address, I need the layer 2 information to get to you. And it's while that ARP packet is being sent out and we're waiting for whoever owns that layer 3 IP address to reply back to say, hey, I'm over here. I'm over here. Here's my layer 2 address. Here's my MAC address. While we're waiting for that process to get worked out, and remember, the switch 3 needs to know that MAC address. Switch 2 needs to know the MAC address of the server over here. And switch 1 probably knows it because it's plugged in here, right? But all the switches need to know, they need to learn about the MAC address for the left server so that they know where to send the traffic, out which port the traffic is going to go. And so while that ARP process is taking place, the first ping packet is going to get dropped. You're going to get the period. And depending on how long the daisy chain is and what's involved, the second ping packet might get dropped, right? Because those ping packets are timing out, because we're not getting a response because the path with the MAC addresses or the MAC address for the left server hasn't been built. So let's see what happens here. I hit enter, and of course, Packet Tracer doesn't cooperate with me, and it immediately pings out and it works. So we'll assume that the first packet would have dropped, which is what would have happened in the real world here. And I say ARP-A, and now what do we get? We get the layer 3 to layer 2, or sometimes I hear layer 2 to layer 3 information. So this layer 3 address has this layer 2 address. Now here's what's important. Let's come to switch 3 now, and let's say show MAC address table. Well, what was the address? What did it end in? 46 echo 6. And let's hopefully here, this is going to cooperate. And there it is. 46 echo 6 was learned through gig 02, which is this port right here. So when the ping traffic shows up here, and this is after the ARP has been done, right? The traffic now shows up here, And remember, if we're looking at that 7-layer OSI model, layer 1, those are the bits, right? The electromagnetic signals that are traveling across the wire. Then the switch is going to see, when all that stuff gets here, the switch is going to look at the layer 2 information. And in here, there's a source MAC address so that it knows how to get back to the server on the right-hand side. And there's a destination MAC address. And remember, that was what that Arp request was facilitating, getting the layer 2 information, because in the packet that it crafts up here and sends, switch 3 looks at the destination MAC address and it says, oh, you're trying to get to 46 echo 6. I know that I send that traffic out this link right here. So then the traffic, the ping packet gets sent over here. And we come to switch number 2, where we say, show MAC address table. And here's the 46 echo 6. And switch 2 says, yeah, I learned that information and I learned it on gig 01. Well, let's click on our topology, hover over the link. There's gig 01. So on that port right there, switch 2 learned that MAC address, that layer 2 address. So now switch 2 that just received the frame here says, excuse me, now I send the frame over here, out this port to whatever's on the other side. The frame gets here to switch 1. So we come on to switch 1. And again, you can see at no time are these switches looking at the layer 3 information. They don't care because they're incapable of routing the traffic based on the IP. They're using the layer 2 address, the MAC address. So then we come over here to switch number 1, where I set a password, and we're going to get in here, ABC123, and we say show MAC address table, 49 echo 6. Switch 1 says, well, I learned about that MAC address on fast Ethernet 01. So let's hover over the diagram. Fast Ethernet 01 is that port right there. So if I learned about that MAC address on that port, when I get traffic that shows up here and the layer 2 destination address is whatever it was, 49 echo 6, I send it out this port. And when it gets here to the server on the left-hand side, again, remember, layer 1 are the little, the bits that come across the wire. The server looks at the layer 2 destination and says, hey, that's my MAC address. This is for me. And so then it gets rid of the layer 2 header and it looks at the layer 3 information. And it sees the source and destination IP. And then again, layers 4 through 7, it could look, you got the protocol that could be involved in the payload, whatever the data is, right? And then the left-hand side server says, well, now I'm going to reply back. I'm going to send an ICMP echo reply. And at this point, it knows the source MAC address because that was in the frame that showed up. And it knows the source IP, which is the right-hand side server, which generated the request. So now it packages everything up and it sends it over here because it knows that it sends its traffic to switch 2 based on its ARP cache because it has the layer 2 and layer 3 information. And the process is just reversed, where the source and destination MAC addresses are now switched because the left-hand side server is sending traffic this way. And each switch looks at the layer 2 destination, which is now the right-hand side server's MAC address, and it makes it all the way back to the right-hand side server, right? So is everybody with me on that? That's how layer 2 switches are making their decisions. Remember, the layer 2 switch doesn't look at the IP. It doesn't care. it needs the MAC address, right? Does that make sense? I'm just quick temperature check here.
No, you're explaining it fine.
Okay.
Yep.
All right. So that's how this is working. All right. So here's how we're going to wrap up. And again, I'm a little bit over and I apologize. So here's what we're going to do to wrap up. You're now going to put an IP on all three of the PCs, right? And obviously a different IP. You're then going to save your configuration. And this is what you're going to email to me. So all of these devices, the switches and the PCs and the servers, are all going to have their own individually unique IPv4 address in the 192.168.1, and test. See if you can ping all of the devices. And then you're going to come up here, you're going to say File, Save As, and you're going to go ahead and throw your name in here. You know, my name dash Zoom number 2, Zoom number 2, and then maybe the date 02/01/2021. You're going to save that. You're going to pack it into an email and you're going to fire it to me. So before we leave, quick review here of what we have on the syllabus for tonight. And that is, for this week, I should say. You have IP assignment 1, IP assignment 2. The video tutorials for these will be up tomorrow. And I'm going to break them down, and let's take a look at assignment 1. And you can see there's going to be 30 questions. I'm going to break the videos down. Questions 1 through 10, it's going to be its own video. 11 to 15, its own video, so that they're shorter and that they're focused on those conversions specifically, so that if you're interested in, you know, I know how to convert binary to decimal, that's easy for me, but the hex I'm a little confused on, you'll know exactly what video that you could go to get an explanation, right? And then we'll do a video for the classes. And the same thing is true of IP assignment 2, okay? So those videos will be up tomorrow if you wanted to get additional assistance. You've got the module 1 through 3 chapter exam. You have 10 attempts on that. 10. 2-hour time limit, right? Remember, it's a pool of questions. So you're not going to be seeing the same questions every time. Now, you might see a couple that are the same, but they're not going to be the same every time. So make sure that you're ready to go. Remember, your highest score is the score that is kept. And then the skills 1 activity, there's already a video for that. And again, I'll pack those links in so that those are available to you. So before we cut out tonight, any final questions?
No.
All right. So wait, somebody hit me something in the chat. Yeah. So Ricky, if your servers can't talk to one another, double check that the IPs are in the same subnet, the 192.168.1. whatever, and that you've got links between all your switches. And again, excuse me, go ahead and run your pings. And then if you can't ping the between the servers, try to simply ping the switch that the server's plugged into and see if that works. All right, well, let me go ahead here and let's kill this recording. And again, I'll have the recording up.